3I/ATLAS just broke apart. And what we're witnessing isn't a random comet disintegration, it's a controlled separation that has completely changed the threat assessment for Earth. Tracking stations worldwide detected the split approximately 36 hours ago. Atlas, the mysterious interstellar object that's been defying physics since we first observed it, suddenly divided into two distinct fragments. Each piece is roughly half the size of the original object, approximately 400 meters across, and both fragments are now maneuvering independently toward Earth on separate trajectories. But here's what's sending shockwaves through the astronomical community. This wasn't a natural breakup. Natural objects that fragment in space create chaotic debris fields with pieces flying in random directions at varying speeds. Atlas separated cleanly into two equal-sized fragments that immediately began executing independent course corrections. Within hours of the split, both pieces were actively maneuvering using their own propulsion systems. We're not watching a comet fall apart. We're watching a spacecraft that just divided itself into two operational vehicles, each apparently capable of independent navigation and mission execution. And both are heading directly toward Earth on trajectories calculated to arrive at our planet from different directions simultaneously. Before we break down what this split means and why both fragments arriving together is so strategically alarming, hit that subscribe button and drop a like, because this just became a two-object crisis and we need to track every development. The question isn't whether ATLAS could split anymore, we watched it happen. The real questions are, why did it divide itself, and what happens when both fragments reach Earth at the same time? Let's examine exactly what happened during the split, because the details reveal this was absolutely intentional and meticulously planned. Multiple observatories captured the separation event. Atlas began emitting unusual electromagnetic pulses approximately 2 hours before the split. These weren't the communication signals we'd detected previously. These were high-energy bursts focused internally, apparently activating separation mechanisms within the object's structure. An aerospace engineer analyzing the event described it as engineered. What we observed matches procedures for spacecraft separation, the kind of controlled division where one vehicle splits into two independent craft. There were preparatory energy pulses, structural releases, and then a clean separation along what appears to be a designed seam. This was built to split. The separation itself occurred over approximately 8 minutes. Atlas's two halves moved apart gradually at first, maintaining parallel orientation for several minutes. Then small thruster burns from each fragment pushed them further apart, creating distance between the two pieces while keeping them on similar trajectories. What's extraordinary is that both fragments remained fully operational after separation. Each piece immediately began generating its own electromagnetic emissions, showing independent power systems. Each started making navigation adjustments, proving autonomous control, and each demonstrated the same impossible capabilities that ATLAS showed before the split: propulsion, maneuvering, active scanning. A spacecraft systems specialist explained the significance. Designing a vehicle to split into two independent operational units requires incredible engineering. You need duplicate power systems, redundant propulsion, separate control systems, and mechanisms to maintain both pieces after separation. This isn't accidental fragmentation, this is modular spacecraft design at a level we've never achieved. The split also released something else that has researchers deeply concerned. Observatories detected dozens of smaller objects emerging from the separation point, tiny fragments between 1 and 5 meters in diameter spreading out into space. These aren't debris. They're moving under power, taking up positions between the two main fragments like they're establishing a communication or sensor network. Multiple tracking stations confirmed that these micro-objects are actively maneuvering. They're maintaining specific geometric formations relative to the two main fragments, creating what looks like an interconnected system spanning thousands of kilometers of space. The timing of the split is also significant. Atlas divided itself at a point in its trajectory where both resulting fragments could reach Earth efficiently. If it had split earlier or later, the pieces would have required much more energy to achieve current approach vectors. The separation was timed for optimal mission continuation. The really alarming aspect of this split isn't just that we now have two objects to track, it's where those objects are going and how they're getting there. Fragment A, the larger of the two pieces by a small margin, is approaching Earth from what's called the prograde direction, coming in along the plane of Earth's orbit around the Sun. Its trajectory will bring it toward Earth's dayside, approaching with the Sun behind it from our perspective. Fragment B is taking a completely different route. It's maneuvering to approach from above the ecliptic plane, the flat disk where planets orbit the Sun. This fragment will arrive at Earth from a steep angle, coming in over Earth's North Pole region. An orbital mechanics specialist described the strategic implications. These aren't random trajectories resulting from a breakup. These are calculated approach vectors designed to reach Earth from different directions simultaneously. It's classic military doctrine, approaching a target from multiple vectors to divide defensive attention and complicate response. Current projections show both fragments will arrive at Earth within a 6-hour window of each other, approximately 18 to 21 days from now. Fragment A will reach Earth orbital distance first, followed by Fragment B arriving from a completely different direction, while Fragment A is still in our vicinity. The approach velocities are also carefully controlled. Both fragments are making periodic thrust adjustments to maintain their synchronized arrival timeline. When one fragment's trajectory analysis shows it pulling ahead, it makes small braking burns. When the other falls behind, it accelerates slightly. They're actively coordinating to arrive together. But the trajectories serve another purpose beyond synchronized arrival. By approaching from different directions, the fragments will have unobstructed views of different regions of Earth. Fragment A, approaching from the solar direction, will observe Earth's dayside and the hemisphere facing away from the Sun during approach. Fragment B, coming from above, will map polar regions and have a different perspective on Earth's surface. Between them, the two fragments will achieve complete observational coverage of Earth during their approach. No blind spots, no unexplored regions. If this is reconnaissance, it's incredibly thorough. If it's something else, the dual perspectives provide tactical advantages we can only speculate about. The micro-objects released during the split are also positioning themselves strategically. They're spread along both approach trajectories, creating what looks like relay stations or navigation beacons marking the path to Earth. Some have taken up positions ahead of the main fragments, possibly conducting advanced scouting. Others trail behind, potentially providing rear observation or communication links. A space surveillance analyst described the formation as military grade. The positioning of these objects shows coordinated mission planning. Main assets approaching from multiple vectors, supporting elements providing overwatch and communications, advanced scouts gathering intelligence. If I saw this formation approaching Earth from a hostile nation, I'd recognize it immediately as a multi-axis attack profile. The question that has scientists, military analysts, and government officials debating intensely is, why did Atlas divide itself at this specific point in its journey? Several theories are emerging, each with different implications for Earth. The most optimistic theory is redundancy and survivability. By splitting into two independent objects, ATLAS ensures that if one fragment is damaged or destroyed, the other continues the mission. It's exactly what we'd do if we were sending a probe into potentially hostile or dangerous territory. Build in redundancy so mission completion isn't dependent on a single asset surviving. A mission planning specialist explained this approach. Deep space missions often include redundant systems because the stakes are so high. If Atlas is conducting scientific exploration of our solar system, splitting into two units means damage to one doesn't end the mission. It's logical risk management for high-value operations. But there's a more concerning theory, force multiplication. Two independently maneuvering objects create more complex challenges for tracking and response than one larger object. Defense systems designed to address a single target have to recalculate when facing two simultaneous threats from different directions. A defense analyst described the tactical advantage. The moment ATLAS split, it changed the strategic calculus completely. Now we're tracking two objects, projecting two trajectories, planning for two simultaneous arrivals. Our surveillance resources are split between monitoring both fragments. Our response capabilities have to address dual scenarios. From a military perspective, ATLAS just made itself a much harder problem to solve. There's also a specialization theory. Perhaps the two fragments have different capabilities or missions. One might be optimized for scientific observation while the other focuses on communication. Or one could be designed for atmospheric entry while the other remains in orbit. Splitting allows each piece to execute specialized tasks simultaneously. But the timing suggests another possibility that's deeply unsettling: preparation for something specific at Earth. Atlas waited until it was close enough to ensure both fragments could reach Earth efficiently, but far enough out that it had time to verify both pieces were operational and properly coordinated before final approach. That's the timing you'd choose if the split was preparation for a coordinated operation at the destination. The energy signatures from both fragments have also changed since the split. Each is generating more intense electromagnetic emissions than ATLAS did before separation. It's as if the split unlocked additional capabilities or activated systems that weren't running when ATLAS was intact. A systems engineer analyzing the power signatures described them as elevated. Both fragments are operating at higher energy levels than we'd expect if they simply split from a larger object. They're not running at half power. They're each running at near full capacity. That suggests the split wasn't about dividing resources. Each fragment has full operational capability. The split has triggered frantic international responses as governments realize they now face a two-object scenario with all the complications that entails. Space tracking networks worldwide immediately had to double their monitoring efforts. Every telescope, radar system, and observation platform that was tracking ATLAS now has to track two objects simultaneously on diverging paths. That's straining surveillance capabilities and revealing gaps in our coverage. A space surveillance coordinator described the challenge. We built our tracking systems assuming we'd monitor one object at a time or handle debris fields from random breakups. We weren't prepared for one object deliberately splitting into two fully operational units going separate directions. We're scrambling to maintain adequate coverage of both fragments. Military space commands have activated additional assets to maintain continuous observation. Satellites are being repositioned. Ground-based radars are being brought online ahead of scheduled maintenance. The urgency is palpable. Nobody wants to lose track of either fragment even briefly. Defense planners face an even bigger challenge. How do you prepare defensive options against two targets approaching from different directions? Missile defense systems are designed to handle threats from specific vectors. Atlas's fragments are coming from different angles, potentially overwhelming systems designed for single-axis threats. A missile defense specialist explained the problem. Our defensive architecture assumes threats come from predictable directions: ballistic missiles from adversary nations, asteroids from specific orbital paths. Fragment A and Fragment B are approaching from vectors that complicate interceptor positioning. We'd need to divide defensive assets between two targets, reducing capability against each. International coordination is also breaking down under the strain. Some nations want to attempt communication with both fragments simultaneously. Others advocate for defensive posturing against both. A few are proposing that different nations take responsibility for monitoring different fragments, but that raises questions about information sharing and coordinated response. The United Nations scheduled emergency sessions specifically addressing the dual object scenario. Representatives from space-capable nations are debating whether splitting tracking and response responsibilities is feasible or whether centralized coordination is essential despite political complications. A diplomatic source described the meetings as tense. Nations are arguing about whether to treat the fragments as separate objects or parts of a unified system. If they're independent, maybe different nations can engage with different fragments. If they're coordinated, we need unified strategy. Nobody knows which framework is correct, and we're running out of time to decide. As both fragments continue their approach toward Earth, their behavior is providing clues about capabilities and possible intentions. And what we're observing is both fascinating and increasingly alarming. Both fragments are conducting intensive scanning of Earth. The electromagnetic emissions from each show characteristics of active sensor systems, radar, spectrographic analysis, possible LiDAR mapping. They're not just approaching blindly, they're gathering detailed information about our planet as they close the distance. But each fragment appears to focus on different aspects. Fragment A's transmissions include frequencies optimal for atmospheric analysis and surface mapping. Fragment B's signals show patterns consistent with monitoring electromagnetic emissions from human technology, radio, television, satellite communications, radar installations. A remote sensing specialist analyzing the signals described the division of labor. It's like they split the reconnaissance mission between them. One fragment studies Earth as a planet, atmosphere, oceans, land masses. The other studies Earth as a civilization, our technology, communications, energy signatures. Together they're building a comprehensive intelligence picture. The micro-objects released during the split are also active. They're transmitting data back to both main fragments and apparently communicating with each other, creating a distributed sensor network. Some have maneuvered into positions where they can observe both fragments simultaneously, possibly providing coordination data. Recent observations show both fragments are making subtle trajectory adjustments that suggest they're aiming for specific positions around Earth. Fragment A appears targeted for an orbital position that would place it over the Pacific Ocean initially. Fragment B's trajectory suggests it will position itself over the Arctic region. An orbital analyst explained the significance. They're not just approaching Earth randomly. They're calculating insertion points that provide optimal coverage of different regions. Between them, they'll have line of sight to most of Earth's surface when they arrive. That's either thorough scientific observation planning or comprehensive tactical positioning. Both fragments have also begun time-synchronized activities. Every few hours, both simultaneously increase their electromagnetic transmissions for exactly the same duration, typically 11 to 17 minutes, then return to lower emission levels. The synchronization suggests they're coordinating activities, possibly reporting status to each other or to some other entity we haven't detected. The power signatures from both fragments continue to increase as they approach Earth. Either they're activating additional systems in preparation for arrival, or they're charging energy storage in anticipation of intensive operations. Both possibilities suggest the approach phase is preparation for something more active once they reach Earth. Behind closed doors, military planners worldwide are gaming out scenarios for responding to the dual fragment approach. And the simulations are revealing uncomfortable truths about humanity's limited options. The most obvious defensive option, kinetic impact to destroy or deflect the fragments, faces significant challenges. Any kinetic impactor would take days or weeks to reach either fragment's position. That's enough time for the fragments to observe the launch, calculate the interceptor's trajectory, and maneuver to avoid impact. A space defense engineer explained the problem. We can launch interceptors, but they're not fast missiles. They're spacecraft that need time to reach their targets. Atlas's fragments have demonstrated they can detect and respond to threats. An interceptor would be visible from launch. They'd have plenty of time to evade. Nuclear options are being discussed, but face even more complications. Detonating nuclear weapons in space violates international treaties and could create electromagnetic pulses affecting our own satellites. And if the fragments survive nuclear detonation, which their demonstrated resilience suggests they might, we've shown our best weapon and it didn't work. There's also the dual target problem. Even if we could deploy effective weapons against one fragment, we'd need to simultaneously address the other. Dividing our limited defensive capability between two targets means each gets partial attention and reduced effectiveness. But perhaps the most serious limitation is that we don't actually know if the fragments are threats. Destroying them based on perceived danger when they might be peaceful scientific missions could be humanity's first act in the galactic community. And that act would be violent aggression. A military ethicist described the impossible decision: do we treat the fragments as threats and attempt to destroy them, risking that we just attacked peaceful explorers and made enemies of a vastly superior civilization? Or do we assume good intentions and let them approach unhindered, risking that they're hostile and we've given them free access to Earth? There's no good answer. Some defense planners are focusing on Earth-based preparation rather than space-based interception, hardening satellite systems against potential electromagnetic warfare, preparing power grids for possible disruption, positioning emergency response assets for scenarios ranging from local impacts to global effects. The dual-approach trajectories complicate even these preparations. A Fragment A approaching over the Pacific means West Coast nations need different preparation than Fragment B approaching over the Arctic, which affects completely different regions. Resources have to be spread globally because we don't know which fragment, if either, might create effects requiring response. With both fragments now 18 to 21 days from Earth, every day brings new developments in their approach and new challenges for preparing humanity's response. The fragments continue their precisely coordinated approach. Recent trajectory calculations show they're maintaining their 6-hour arrival window with remarkable precision. Whatever coordination system they're using, it's allowing two independent objects to synchronize their movements across millions of kilometers of space. Both fragments have begun deploying additional micro-objects as they get closer to Earth. These new releases aren't taking up positions along the approach trajectory. They're spreading out perpendicular to the approach paths, extending the sensor network in multiple directions. A sensor analyst described the pattern. They're building a three-dimensional observation grid around their approach vectors. Whatever they're planning to do at Earth, they want comprehensive situational awareness of the space environment before they arrive. That's sophisticated operational planning. The electromagnetic transmissions from both fragments have evolved to include what appear to be countdown sequences, similar to those detected from ATLAS before it split. But now there are two countdowns, one from each fragment, and they're synchronized to reach 0 at slightly different times, approximately 6 hours apart. Current analysis suggests Fragment A's countdown reaches 0 when it achieves Earth orbital distance. Fragment B's countdown zeroes out 6 hours later when it arrives at its calculated position. Whatever the countdowns represent, they're marking specific moments in each fragment's individual timeline. Recent deep space observation has also detected something concerning: increased activity from those mysterious escort objects that have been shadowing ATLAS throughout its journey. These escorts, 5 artificial objects that have maintained formation with ATLAS since before it entered our solar system, are now positioning themselves in what looks like a protective formation around both fragments. A military space analyst described the formation as defensive. The escorts are taking up positions that would allow them to intercept any objects approaching either fragment. If we attempted to send probes or weapons toward Fragment A or B, they'd have to get past those escorts first. It's a protective screen, possibly covering both fragments' final approach to Earth. In less than 3 weeks, we'll face something unprecedented in human history. 2 independently operating objects of alien origin arriving at Earth simultaneously from different directions. What happens next depends entirely on capabilities and intentions we can only guess at. Best case scenario, both fragments are peaceful scientific probes conducting coordinated observation of Earth from multiple perspectives. They gather data, possibly attempt communication, and eventually depart having completed their mission. Humanity learns we're not alone and gains knowledge from observation of advanced technology. But there are so many other scenarios. The fragments might attempt to establish permanent presence around Earth, monitoring us indefinitely. They might deploy additional objects, satellites, probes, or other technology into Earth orbit without asking permission. They might attempt to land on Earth's surface, either openly or covertly. The coordinated arrival suggests whatever they plan requires both fragments present simultaneously. That coordination could be for comprehensive observation, redundancy in case one fails, or something more complex we haven't considered. A strategic analyst summarized humanity's position. We're about to host two visitors from beyond our solar system, arriving at the same time from different directions after deliberately dividing from a single object. They've demonstrated technology vastly superior to ours, shown they can operate anywhere in the solar system, and carefully timed their arrival for maximum coverage of Earth. We don't know if they're friends, observers, or something else entirely. The split changed everything. What was one mysterious object is now two independently capable vehicles approaching Earth in coordination. The complexity increased, the unknowns multiplied, and our time to prepare is rapidly running out. Atlas split in two. Both fragments are coming, and in less than 3 weeks, we'll discover whether that split was for scientific redundancy, tactical advantage, or purposes we haven't even imagined. What do you think the split really means? Why divide into two objects that arrive together? And what happens when both fragments reach Earth from opposite directions? Share your thoughts below and stay subscribed, because when those two fragments arrive in 3 weeks, we'll all witness together whether this dual approach is humanity's greatest opportunity or our biggest challenge.